Hello, my name is Callie Steiner, and this is my final project for Geography 101. Today, I'll be presenting on Hurricane Katrina and its impact on global sediment loss. This topic is important not only because of the human tragedy involved, but also because of the long-term environmental consequences that continue to affect coastal regions today. Throughout this presentation, I will explore how Hurricane Katrina accelerated sediment loss, why that matters on a global scale, and how this disaster connects to broader themes we studied throughout this course. In late August 2005, Hurricane Katrina became one of the deadliest and most destructive natural disasters in the United States history. Originating over the Bahamas, Katrina rapidly intensified in the Gulf of Mexico, reaching Category 5 status before making landfall along the Gulf Coast as a strong Category 3 hurricane on August 29th. The storm devastated parts of Louisiana, Mississippi, Alabama, Texas, Florida, and Georgia, but its most catastrophic effects were felt in New Orleans. The city, which sits largely below sea level, suffered catastrophic flooding after its levee system failed in more than 50 locations. Over 1,800 lives were lost, and hundreds of thousands of residents were displaced from their homes. Beyond the human tragedy, Hurricane Katrina also caused severe environmental damage, particularly along the Louisiana coast, where entire wetlands and barrier islands were submerged or permanently altered. One of the most lasting and overlooked consequences of the storm was its role in accelerating sediment loss in the Mississippi River Delta. This is an issue that has profound implications, not only for Louisiana's coastline, but also for global coastal systems and land stability. My thesis statement is, Hurricane Katrina was not only a devastating natural disaster for the Gulf Coast, but also Hurricane Katrina wasn't just a local disaster. It had long-lasting environmental consequences that reached far beyond New Orleans. The storm caused major sediment loss and severe coastal erosion along the Gulf Coast. This exposed serious flaws in how we manage and protect our coastline.
Climate change and poor environmental
As a result, Katrina became a global wake-up call that pushed scientists, governments, and communities around the world to take coastal resilience and environmental planning much more seriously. Hurricane Katrina had an immediate and devastating impact on both human life and the environment. When the storm made landfall on August 29, 2005, it overwhelmed communities across the Gulf Coast, particularly in New Orleans, where the failure of over 50 levee systems caused catastrophic flooding. In just hours, nearly 80% of the city was submerged, leaving thousands of people stranded on rooftops or in shelters with no access to clean water, food, or medical care. Tragically, more than 1,800 lives were lost and over 1 million residents were displaced, many of whom never returned, in terms of financial damage. Hurricane Katrina became the costliest natural disaster in the United States history, with damages totaling around $125 billion. But beyond these well-known statistics lies an equally urgent consequence: the destruction of the coastal landscape. The storm's high winds and storm surge wiped out more than 200 square miles of coastal wetlands and barrier islands, natural defenses that once protected inland communities from storm damage. This dramatic loss of sediment-rich land happened almost overnight and exposed just how vulnerable the Mississippi River Delta region had become. These wetlands were already under pressure from decades of human development and river engineering. But Hurricane Katrina dramatically accelerated their erosion and collapse. This moment marked not just a humanitarian and economic crisis, but an environmental one as well, one with long-term consequences for the region and lessons for coastal communities around the world. Hurricane Katrina left a lasting geological mark on the United States, especially along the Gulf Coast. One of the most immediate and devastating effects was massive coastal erosion. Entire stretches of shoreline and barrier islands were reshaped, with some areas permanently lost to the Gulf of Mexico. The storm also destroyed over 100 square miles of vital wetlands, which act as a natural buffers against storm surge and help trap sediment. Without them, land loss accelerated and the region became even more vulnerable to future disasters. Hurricane Katrina significantly disrupted the natural sediment distribution of the Mississippi River, pushing vast amounts of sediment into open waters rather than allowing it to rebuild land in the delta. This interruption, along with the storm surge and widespread flooding, intensified soil compaction, altered the underground water table, and accelerated land subsidence, particularly in vulnerable areas like New Orleans. Hurricane Katrina had a massive impact on both the population and geography of the United States. It caused mass displacement, forcing over 1 million people to flee their homes, with many never returning, leading to permanent relocation for hundreds of thousands. This resulted in major demographic shifts, especially in southern cities that absorbed large numbers of evacuees. The disaster triggered a widespread mental health crisis, with many of the residents and survivors experiencing long-term trauma. There was also a sharp spike in homelessness, as families struggled to find stable housing in labor market chaos, with job losses disrupting the economy across the Gulf Coast. Although Hurricane Katrina directly struck the United States, its environmental impact extended far beyond American borders and had significant global implications. The destruction of the United States wetlands, especially in Louisiana, severely reduced global carbon storage capacity, which plays a critical role in regulating the Earth's climate. These wetlands also supported migratory bird habitats and international fish populations, so their loss disrupted ecological systems that spans continents. Katrina served as a wake-up call for the international community, highlighting the vulnerability of coastal regions to rising sea levels and increasingly intense storms. In response, several countries, including the Netherlands and Bangladesh, reevaluated and strengthened their flood defense systems to prevent similar disasters. The storm also reinforced the urgent need for global disaster preparedness and climate resilience planning. Around the world, governments, scientists, and city planners began having more serious conversations about climate change, extreme weather patterns, and the importance of sustainable urban development. In many ways, Hurricane Katrina was not just an American disaster. It was a global warning. Hurricane Katrina caused serious damage to the U.S. economy, especially in the Gulf Coast region. It led to more than $125 billion in damages, making it one of the most expensive natural disasters in American history. Important industries like oil, shipping, fishing, and tourism were heavily affected. The storm hit the Gulf of Mexico, which is an important area for the U.S., because of its ports, oil refineries, and offshore drilling. New Orleans, a major city for business and tourism, lost many jobs and billions of dollars. Gas prices went up across the country due to the damage to oil rigs and refineries. The U.S. government had to spend billions of emergency help in rebuilding. Insurance companies also lost large amounts of money, which made insurance more expensive for many people. Poorer communities, especially those in low-lying areas that flood easily, took years to recover. Property values dropped, jobs were lost, and people didn't want to invest in those neighborhoods. Hurricane Katrina didn't just cause damage, it changed the economy and the geography of the whole region. Even nearly 2 decades later, the legacy of Hurricane Katrina continues to shape how we approach environmental and urban planning. Its aftermath revealed how deeply intertwined climate, infrastructure, and social vulnerability truly are. The disaster exposed the long-term consequences of neglecting natural buffers like wetlands, and it emphasized the importance of investing in resilient infrastructure before, not after, catastrophe strikes. Today, Katrina is still studied in classrooms, research labs, and policy meetings as a turning point in disaster response and climate adaptation. It reminds us that the challenges of rising seas, disappearing coastlines, and extreme weather are not future problems. They're happening now, and they require urgent, coordinated global action. This project closely ties into the core themes of our class Geology 101 by examining the relationships between Earth's natural processes and human activity. Hurricane Katrina acts as a real-world example of key geological concepts, including coastal erosion, sediment loss in deltaic environments, land subsidence, and the impact of extreme weather on surface features. It also highlights how human actions, like wetland destruction and inadequate environmental planning, can intensify natural disasters. By studying Katrina through a geological lens, we gain a deeper understanding of how the Earth's systems function and how human decisions can influence those systems over time. These are key themes in physical geography and geology, particularly in understanding how landscapes are shaped over time and how vulnerable regions are affected by natural forces. By studying Katrina, we can apply these concepts we've learned, such as landform processing, environmental hazards, and sustainability, to a major historical event that still influences disaster preparedness and environmental policies today. Hurricane Katrina had a major geographic impact on both the United States and the world. It dramatically reshaped the Gulf Coast, destroying over 100 square miles of wetlands and coastlines, and changing the physical layout of the region. In New Orleans, the failure of the levee system led to severe flooding, permanently altering the city's landscape and infrastructure. The storm also caused the mass displacement of over 1 million people, leading to long-term population shifts and changing the geography of urban areas across the South. Cities like Houston and Atlanta saw increases in population, while New Orleans experienced a sharp decline. On a global scale, Katrina raised awareness about the geographic vulnerabilities of coastal cities, especially in the face of climate change and rising sea levels. The loss of wetlands also had environmental consequences, disrupting ecosystems and reducing natural protection against future storms. Katrina's impact went far beyond a single region. It became a global example of how geography and human life are deeply connected. Hurricane Katrina had a major impact on the United States, both geographically and in terms of population. Geographically, the storm devastated the Gulf Coast by eroding over 100 square miles of wetland, barrier islands, and coastline, which were natural features that once protected the region from storms. In New Orleans, the levee system failed, causing over 80% of the city to flood and permanently altering the physical layout of neighborhoods, roads, and infrastructure. The storm also destroyed important natural environments like wetlands and coastal ecosystems, making the region more vulnerable to future hurricanes and rising sea levels. In terms of population, Katrina displaced more than 1 million people, making it one of the largest population shifts in the United States history. Entire communities were forced to evacuate, and many residents, especially from New Orleans, never returned. This caused the city's population to drop by more than half in the years following the storm. Meanwhile, cities like Houston, Atlanta, and Dallas experienced population growth as they absorbed evacuees. These shifts changed the demographic and urban geography of several major cities. Hurricane Katrina didn't just cause short-term damage, it permanently changed where people live, how cities are built, and how the U.S. prepares for future disasters.